Okay, so this is a particular problem from the regression using technology for linear regression section. And so I'm just going to go ahead and copy this data to the clipboard. And let's go into a Google Sheet. So here's a blank Google Sheet, and I'm going to paste the data in. So edit, paste. So there's my data. Now I'm going to, in order to create a linear regression, we have to create what's called a scatter plot and show the data. So I need to insert a scatter plot. But before you insert the scatter plot, make sure you highlight both columns of your data so that the system knows what data we're trying to create a plot from. Okay? Whatever's on the left side is going to automatically be the explanatory or X variable or input. Whatever's on the right is going to be the effect or output or the Y variable. Okay, so input or explanatory and then output. Okay? So we're using the age to explain the hours that the baby sleeps. Okay? So now let's go ahead and insert a chart, and the kind of chart we want to choose is a scatter plot. So we're going to scroll down until we see scatter. We just want the scatter with just points only. Okay, so here's what our data looks like. And now we want to find the equation of the line that best fits through this data, that minimizes the distance from the points to the line. Okay, so we do that by clicking on Customize. We want to customize what's called the series. The series is essentially a fancy name for the data. And we want to add a trend line. Trend line is sort of Google Sheets' name for a regression line. What kind of trend line? There's lots of different types. So we're going to choose linear. There's lots of different types. And for the label, we're going to label the line with its equation so we can see the equation. And we might as well show the R squared. That's sort of a measure of how well the line's fitting the data. Okay, so my R squared is 0.657, which is reasonably high, so that's a pretty good fit. As if it gets closer and closer to 1 or -1, it becomes a perfect fit to the data. Okay, so it's a pretty good fit, 0.657. So that means none of the data points is that far away from the line. Now, that's it. So this is my trend equation, -2.5x plus 15.8. So if I know somebody's age or an infant's age, I can plug that age in for x, multiply it by -2.5, add 15.8, and that will give me the predicted value for their hours that they will sleep. Okay, so we're using the input or x or horizontal variable or explanatory variable, which is age in this case, as a predictor to predict, by plugging it into this equation, we can predict the hours that they're going to sleep. Now, it might be the case that this is not enough decimal places. Okay, some of the problems want more decimal places. So to get more decimal places, you actually just kind of click into an empty cell, and we're going to say equals, for the slope, we just type SLOPE, and we need to predict, basically it's reminding us that we're going to first highlight the Y data, or output, then comma, and then the input. So you have to go output, comma, input. Okay, so my output is this stuff. This is my output. Then a whoops, let me escape, I went too far there. So equals slope, parentheses, and then I'm going to highlight my Y values. Now it's smart enough to realize if you just highlight the name of the column, it realizes that's a name, it's not data. Okay, it's smart enough to realize that. Okay, and then we put a comma. So the Y values are outputs, then the X values. Okay, close the parentheses, and there we go. Okay, now if you're not seeing enough decimal places there for some reason, either expand your column, make your column wider to give it more room, or you can use these increased decimal operations to ask for more decimals. Okay, you can ask for less decimals here or more decimals. Okay, so that's my slope. That's the exact value of the slope of my regression equation. Okay, notice the -2.499. It's showing me a -2.5 because it's rounding off to 1 decimal place in the label. But they might want more decimals in the answer. Okay, what about the y-intercept, the 15.8? Can I get more decimals there? Okay, so equals intercept. Okay, so we're going to choose the intercept function. Just click once, if you're in Google Sheets, not twice. And again, you have to highlight the output first, the Y values or outputs. Okay, right down to here, comma. Then we're going to highlight the inputs. Close parentheses, enter. Okay, and again, so that's my intercept. I'll just type the word intercept so I can remind myself what that is. Okay, and so basically there I go. Now again, if you need more decimals, just click on the decimal operator to get more decimals. Okay, and notice we're getting 15.782, whereas the rounded off value was 15.8. So they had rounded the 15.782 up to 15.8 for us, but if we need more decimals, there they are. Okay, pretty easy, right? Okay, now you can also use regular Excel for this, but it works pretty much the same. Okay, so here's an Excel blank spreadsheet. I can paste in the data. So let's see, just paste. There we go. Okay, and we'll insert. In this case, I want to insert a chart. And the type of chart I want is a scatter plot. Now why is it? I can already see I made a mistake, right? It's blank because I didn't highlight the data first. Highlight the data. Then we're going to insert a scatter plot. Looks a little better, right? Okay, and then we need to add the trend line. Okay, so in this case you can click on one of your data points to highlight your data, and then right click, and we want to click on add trend line. So right click on your data points, add trend line. Okay, what kind of trend line? We'll choose linear. And we want to, in this case, to show the equation, there's actually in regular Excel, this is not Google Sheets, this is regular Excel, I can just click on display equation and display R squared. Okay, and then I can take the equation and drag it so I can see it, just kind of drag it around. It should move around for you. And again, if that's not enough decimal places, again, you can use equals slope, parentheses, and then the Y values, comma, then the X values, Okay, you don't have to say the do part if you don't want to. Okay, so there's the exact value of your slope. Here's your intercept. How do you get your intercept? Equals intercept. Double click for regular Excel. Y values first. Comma. X values. And there's the exact value of your intercept. Again, you can add more decimals by making the column wider, first of all, to give yourself some room for the decimals. And then click on the cell and use your decimal commands, which are here. That's decrease, this is increase. So I can ask for more decimals if I like. Okay. Whoops, I decreased. We can increase. Okay, whichever you need. And there we go. Okay. And then again, to predict a value, you would just take the X or input, which is the age, and plug it in. Like if they say, you know, let's predict what a baby of 0.6, I guess this is weeks. I can't remember. I'd have to look at the data. But this age, okay, that age, what's the hours of sleep that we're going to predict? We would just plug that age into this equation for X. Okay, if we look at the actual equation, I'm sorry, age in years, my bad, and then the hours slept per day. Okay, so if we said if a baby's like 0.6 years old, how many hours are they going to sleep? Okay, how many hours do we predict they're going to sleep? Okay, now if you're plugging in X values that are within, sort of like between the smallest X and the biggest X that we know about, that's called interpolation, and that's fairly accurate. If you're trying to use an X that's past your last data value, like if they said, you know, let's see what happens if the baby's 1.2 years old, well then you're hoping that the trend continues, but you don't know for sure because you don't have any data out here. So that's called extrapolation, and that's not that accurate. Okay? And that's also a big topic. And that's it. Fun, 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 right? It's not too bad.